Welcome to Stories from the NNI. I'm Lisa Friedersdorf, Director of the National Nanotechnology Coordination Office. Today it's my pleasure to welcome Sudipta Seal, Professor and Chair of Material Science and Engineering at the University of Central Florida. Sudipta, thank you so much for joining us today. Can you tell us a little bit about yourself and how you first got involved in nanotechnology?
Well, thank you, Lisa. In nanoscience, I got involved for a long time back when it was not called as nanoscience. In fact, my doctoral thesis was on photoelectron spectroscopy of surfaces. As you know, photoelectron spectroscopy only deals with 3 to 4 nanometer layer, their chemistry. So it is a nanotechnique. People never talked about nano. But through this technique, I was dealing with understanding the chemistry of nanosurfaces, nanomaterials, nanoparticles, nano thin films, nanopowders, and their application into catalysis, energy, geology back in my graduate student days at Wisconsin. So this was my introduction to nano through photoelectron spectroscopy. And then when I did a postdoc at Berkeley, we did a lot of work on a nano characterization tool to understand surfaces. And then when I joined University of Central Florida, I started to make nanomaterials since nanotechnology was coming in a big way.
So your research spans a lot of different areas. Can you talk a bit about your work in making more effective cancer treatments?
During my undergraduate days back in Indian Institute of Technology at Kharagpur, India, one of the premier institute, my thesis was in undergraduate was to look into rare earth oxide materials for their protection of steels from very high temperature environment. And one of the rare earths are known as cerium oxide nanoparticles, cerium oxide material. I then hopped countries, a master's, Ph.D., but I kept on working on cerium oxide on the side as an inquisitive person. My PhD thesis was on looking into oxidative stress. So I knew about free radical damage and their implication in cells, either for cancer, either for neurodegeneration, or many other disease states where oxidative stress plays either directly or indirectly. It is only when back in 2002 to 2004, through means of a collaboration and multiple collaboration, we find that when I was trying to make the cerium oxide nanoparticle in nanoscale, as you know, this material is a very good market for catalysis, for chemical mechanical polishing of electronic devices. We found something very interesting, that this material also has very good antioxidant activity. So through collaboration based on my PhD thesis of oxidative stress and my nanomaterial history, I was able to put 2 plus 2 together to find out that not only this material can be used as antioxidant, but it also has a regenerative effect because of their lattice structure. Now, if you look at cancer, cancer also deals with oxidative stress, deals with reactive oxygen and reactive nitrogen species, deals with angiogenesis versus anti-angiogenesis. That means, if blood vessels feed to the tumor, if you can cut off the supply of the blood vessels, the cells will not get oxygen and you can really destroy the cell. So cerium oxide, one or few dose, because of its regenerative nature, can really control the reactive oxygen species in the cancer cells, which will enable them for cell apoptotic death and keep the healthy cells alive. So that is a very interesting finding because, as you all know, that in cancer, people always talk about the treatment is the worse than the disease. In fact, in one of the example, when you do radiation treatment, of course, radiation kills everything, cancer cells and the good cells. We have noticed that this nanoparticle in the cancer cell can magnify the radiation, so kills the cell effectively and protect the good cells from the radiation. So it has got both radio protective effect and radio sensitizing effect. That's quite intriguing in nature as well. It's kind of a Warburg effect. But also, it controls the local pH of the cell environment. So think about it. You can now do, if you plan to do a radiation treatment, you can really lower down the dose of the radiation by 10 times possibly, because your particle at the cancer cell will magnify the radiation. But there are also many cancer drugs out there. When we combine them with cancer drugs like cisplatin or doxorubicin, we see a big synergistic effect. So when the nanoparticle kills the cells, or the doxorubicin or the other cancer drug kills the cells, when you combine them together, not combination, but conjugate them together, it actually kills the cell even much more higher. So not only it controls the oxidative stress, but also possibly is acting as a drug carrier, so the drug can be very effective to the cancer site. Like anytime you take drugs, it goes all throughout the body till it goes to the site. A lot of times that drug's ability cuts down from 100% to 50%. So our hypothesis here is not only it acts to kill the cancer cells, but also carries the other cancer drugs effectively. And that's where the synergistic effect is quite high.
So I wanted to get your point of view about the concept of interdisciplinarity. Nanotechnology naturally sits at the intersection of many disciplines. Can you share your thoughts on the importance of interdisciplinarity?
I think in any research, interdisciplinarity is very important, especially in nanotechnology. The interdisciplinarity is even more important because we are not expert on everything. In fact, you can save time and energy and dollars if you really complement each other's expertise. For example, when I worked with Dr. Self or Dr. McGuinness, they have worked on oxidative stress and glaucoma. They have that expertise. Only thing they have to tell me what they're looking for. I don't have to really open up a whole model of oxidative stress model or glaucoma model. That is quite expensive. I can rather focus on developing the nano formulation for specific usage. And this is where the interdisciplinarity is very important, because not only that we can exchange ideas, but the students can visit each other's lab, can learn each other's work. You don't have to get a degree in biology and material science and engineering or physics at the same time. It's quite expensive. But by knowing the subject, your marketability or getting a job, either industry or academic or scientific job, gets much easier. So it is an excellent training for students, career development as well. And nowadays, if you go to anywhere, any system, you're not dealing with just one thing, you're dealing with multiple things. So that will make ready for your tomorrow's career and the skill development and the expertise at the same time. That's the importance of interdisciplinarity, but at the same time, ethics is very important. Like in research ethics, you have to make sure your data is collected right, it's repeated right. But also during collaboration, the chemistry of the collaborators are equally important. So proper acknowledgement to each and every one is very vital for the growth and the survival of any technology, and especially nanotechnology, since it's so interdisciplinary in nature.
What are some of the most significant advancements from your perspective that have been made in nanoscience and nanotechnology over the past 15 or 20 years?
One of the things comes to my mind that I can relate to is the LED lights. All traffic lights has LEDs now. Of course, we don't call it nano, but they're nanoscale materials there. In fact, this day and age, your phone is getting shrinking and shrinking and shrinking. Devices getting faster and faster and faster. As you can see, if you take a chip's cross-section, you will see many, many nano layers out there, which is going to enable you to connect to your family, friends, loved ones across the globe. That's a huge impact to the society. And this is where I have seen how shrinking of technology or nanotechnology has helped tremendously to make a societal impact. The other area will have a huge impact is possibly nanomedicine.
So I want to thank you again for taking the time to talk with me this afternoon. Do you have any closing thoughts that you would like to share with our listeners?
As you know, many times we have diseases that is not curable, or sometimes there are diseases which happen so fast you cannot cure. People die. So I think there are more work to be done that nano will have a tremendous impact in the medical intervention, I believe. Already you see PET scans where the crystals have nano aspects, imaging sciences, but in therapy like stroke, like cancer, like heart attacks, I think these are the areas if nanotechnology can predict, intervene, and deliver therapy right there, you have made a difference. This is a day I want to see that I can see in my lifetime.
Thank you for joining us today for this special 15-year anniversary edition of Stories from the NNI. If you would like to learn more about nanotechnology, please visit nano.gov or email us at info@nnco.nano.gov. And check back here for more stories.